Greetings, mathematicians. Today we will use partial products method to divide whole numbers. This is going to be a method in which you will use your extended fact and powers of 10 knowledge to allow you to break your dividend, or the number that you're dividing up by your divisor, into smaller pieces until you get to 0 or a remainder. Most of the problems today should divide evenly. So I do want you to know that this is a multi-step method and that you need to keep in mind math. Mistakes allow thinking to happen. There's going to be times where you catch a mistake, not to erase your entire problem, but look at that mistake and see where you can go from there. So if you feel frustrated at any time, just make sure you take that deep breath, walk away, come back to it, or move on. So let's look at 63 divided by 3 using the partial products method. And this is a method that I've used in different math programs. I'm actually going to rewrite this so I have some room up at the top. That was 63 divided by 3, I believe, correct? Yep. So the first step, like in all division problems, is understanding that the quotient is going to come from figuring out how many times your divisor, which is this number right here, goes into your dividend, which is 63. So let's start with our extended facts and start recording them. In the past, I've kind of extended this down a little bit to give me some room to work over here. The Envision math program likes you to stack your partial quotients up on top. So I'm going to do the way the Envision does. But I'm going to start thinking of my extended facts. 3 times 1 is 3, obviously. 3 times 10 is 30. 3 times 100 is 300. So 3 times 10 might work for me. So I'd just like to write, 3 times 10 in the column over here to help me remember. So 3 times 10 is 30. So up here you would do where you'd multiply. So 3 times 10. And then down here, you're going to subtract 30 from your dividend. So our next step will be looking at what's left over in that dividend. So I'm going to do that one in orange so you can see the different steps. 3 minus 0 is 3. 6 minus 3 is 3. So right now, a lot of you might be screaming 11, 11, 11. I know 3 times 11 is 33. That's great. If you don't, and you can't remember that fact, you can still use a different partial quotient. So I'm going to still stick with 3 times 10 again for this step. So I know that 3 times 10 again is 30. Make sure you put your 10 up here. Like I said, Envision likes to stack them. We do our subtraction. 3 minus 0 is 3. 30 minus 30 is 0. So I have 3 left over. And we know that 3 goes into 3 one time. So that would be 3 times 1. And then when we subtract that, we get a remainder of 0. See if I can move all this print up for you guys. Yep. Thought I had enough room. Once you hit that magical 0 part there, or you have a number less than your divisor, you know that you've finished your division. So I should have stacked my 3 up here, or 3 times 1, right? So it should have been a 1. So let's add up. Oh, I don't like the way that looks. Move this over a little bit more. There we go. I cannot draw with my mouse today, guys. There's a 1. Okay. So if you look here on your side, these numbers are all of the numbers that we divide times 3 by to divide our 63. These are called your partial quotients. They're also up here. That is the final step of adding those up to find out what your quotient is. So you want to take the parts and make it a whole. Think of it like Legos. These are all my pieces of Legos. I want to build up those Legos to build up my final house or car or whatever I'm building. So 10 plus 10 is 20, 21. So my final answer would be 63 divided by 3 equals 21. And we can check that using inverse operations, correct? We could do 21 times 3. 21 times 3 should equal 63. 3 times 1 is 3. 3 times 2 is 63. So there we go. So let's look at how we can do this with an area model. So take a look at that real quick. So let's think about how we can solve 31 divided by 3 with an area model. This was the method that we were using the other day. So I'm going to go through the same process again by drawing some squares each time. So I'm going to draw my first square in my area model. And I know my 3 is here because that's my divisor. So your divisor always goes on the left. The numbers are your partial quotients. They're going to go on top. So you're going to add them across. So again, I'm going to think of a number. This time I'm going to go with 10 again. So 3 times 10. So I'll put my 10 up here. And then you're going to minus your answer there. So our original dividend is 31. 3 times 10 is, I'm sorry, it's not 31. 63, correct? 3 divided by 63. Yeah, caught my mistake. 63 divided by 3 with the area model. Here we go. So draw my first box. And these boxes are just capturing what you did like in partial products. It's just a different way of looking at it. So here's my divisor. We know the number we're multiplying, and then we're going to subtract from our 63. So here's our 63. So we said 3 times 10 is 30. So I'll put my 30 here. And subtract to get my 33. Now, you have to make sure, again, this number's 0 or less than 3, so 3 can't be divided, so I'll draw my next box, which is my next step. Really not a fan of this mouse to draw, but I left my whiteboard at home, or my document camera at school. So again, now we're going to move into the next step, which is what's left over, which is 33. This time I am going to do it with 11. So I know that 3 times 11 gives me 33. And there's my 0. So again, this is where you're going to add. This is your partial quotients. So your final answer would be 21, because you would add 10 plus 11. So in this step, what you are doing is you're taking your dividend in these boxes, and you're doing your multiplication on the edges. So these will always be your partial quotients. So you're saying 3 times what number gets me closest to 63. In this case, we did 10, which gave us 33 left over. And then here, now we're carrying this 33 back over here. 3 times what number gets me closest to 33? 3 times 11 is 33, so we have 0 there. So we have 10 plus 11 to give me that for that area model. Use which method works best for you. What I will tell you is this. Next lesson on Wednesday, we'll be going over the traditional algorithm. I'm the biggest fan of partial products because sometimes you can't think of that number that divides evenly, perfectly when you're doing long division, the traditional algorithm. Partial products allows you to use those extended facts to chip away and find the answer. So let's look at one more. This one's a little bit harder. Those are problems from the 4th grade curriculum. So this was right out of your 4th grade lesson I taught you last year For those friends who were with me, I think it was like 5, 6. And if you look, there's your area model for the first problem we did. Here's how we did the partial products. Another way that you could do that would be here. They knew that 3 times 20 would give you 60, which I'm sure some of you were screaming and saying. And then they minus the 60, they got 3 left over, and then they knew the 1. So they did it that way. So there's multiple ways to solve these. It depends on your fact knowledge, what pops in your brain at that time with your multiplication facts. Because in division, that inverse operation multiplication is essential to get division problems. So let's look at number 3 on your independent practice. This is going to be on page 336. And I'm going to do this one with the first method I showed you. So that's 210 divided by 15. I'm going to do this in blue. So we have our 210, I guess it's green, not blue, divided by 15. Ooh, that's a squiggly line. There we go. Remember, I like to extend the division house down a little bit. It gives me my area here to show my work for what I'm doing multiplication-wise to solve the partial quotients. So again, I'm going to just go right to my extended facts. That's my go-to strategy. I like to do that. You might be doing your factors of 15. You might be saying to yourself 15, 30, 45, so forth. I like to say, let's go with 10. So 15 times 10 again gives me 150. We know that this 10 needs to go up here. I'm going to write really small. That way you guys can see it. Okay. 150 is being subtracted from 210. That would leave me with 11. So it's 60. Okay. Now we know I can't do 15 times 10 because that's 150. Now you really do have to start thinking of your factors of the number that's in your divisor, which is 15. So 15 times 2 is 30. I can go that way. I could subtract 30 and then another 30. However, 15 times 2 is 30. 15 times 4 should be 60, correct? So 15 times 2 is 30, 15 times 3 is 45, 45 plus another 50 is 60, right? Just to show my math there, we knew that 15 times 2 is 30, 15 times 3 is 45, times 4, we're adding another 15, 5 plus 5 is 10, 1 plus 4 is 5, but you got to carry that 1 over from the 10, so really that would be 60. So we know that's the route we want to go. So I'm going to do 15 times 4. That gives me 60. Make sure you add your 4 up here. And then we have 0 left over when we subtract those, correct? 15 times 4 is 60. So my final quotient would be 10 and plus 4 is 14. So 14 is my final answer. And if you want to put your final answer over here, or at the bottom, just circle it. So when you get to your final answer, geez, I cannot draw a 1 with this mouse today, guys. Just circle it. And then that way I'll know where to look. Mrs. Willingham will know where to look. Miss Ware will know where to look. Miss Atkins will know where to look. Alright, friends. So the big thing to remember when you're doing this is to make sure you are very careful with your work. See how I took my time. Make sure that you do this on scratch paper. If you're stuck, I suggest using your extended facts. And then work your way down to making that quotient a 0, and then adding up your parts as you go along. The mistakes I generally see are two mistakes that happen. Students did not add up their partial quotients, their pieces, like the 10 and the 4 here, correctly. They didn't record them correctly, which caused them to add them up incorrectly, or they made a multiplication error. So it's sometimes, like I did a little scratch work to show you there, sometimes I mix up my multiplication facts on purpose and also on accident, that you might need to use that paper. But don't have numbers all over the page. Try to keep your problem nice and neat, lined up, working your way down. It's going to help you when we move into other methods. So feel free to use that or the area method that was shown here in your book. And good luck. I can't wait to see what you come up with.